Okay, so we're talking about kinetic energy and power now, so we're going to continue with what we left off with. Last time we talked about kinetic energy as 1/2 the mass times the velocity squared. Now, in order to have kinetic energy, we need to have velocity, so that means it's moving. So this is energy of motion, and your units for kinetic energy, since it's energy, is the joule, and we abbreviate that capital J. So there's our SI units for energy. Our potential energy, we said if we're talking about gravity, is mgh, and that also has units of joules. So let me ask a question. If we have two objects, let's call object 1 ball A and object 2 ball B. And the object A, ball A, has a mass little m, and we're going to consider the second ball, ball B, as having 3 times the mass of the first ball, A. So ball B has triple the mass of ball A. And ball A, let's say, is moving at velocity v, and ball B, which has triple the mass of ball A, is going to be moving, let's just say for our example here, triple the velocity of ball A. So ball B is going to move at 3 times the speed or velocity of ball A. And I want to know, how does the kinetic energy of ball A and ball B compare with each other? So if I look at the kinetic energy for ball A, it's 1/2. The mass of ball A is m. The velocity of ball A is v. So we're going to square that. And that's what we get for the kinetic energy of ball A. But now let's look at the kinetic energy of ball B. The kinetic energy of ball B is going to be 1/2. The mass of ball B is 3m. You see that? Ball A, mass is m. Ball B, mass is 3 times that of A. It's triple the mass. So we have to put in here 3 times the mass. And now the velocity of ball B is 3v, 3 times the velocity of A. And that whole thing has to be squared, because you've got to take the entire velocity of ball B in this equation and square it. So when we do that, just do a little math here, we're going to have 1/2 3m. This whole quantity squared is going to become 9, because 3 squared is 9. And this is going to be v squared, because 3v times 3v, which is 3v squared, is 3 times 3 is 9, and v times v is v squared. So this is what we get here. When we look at that a little bit further and break that up, we see we're going to have a 3 here and a 9 here. 3 times 9 is 27. So let me just move the 27 out. And then what's left is 1/2 mv squared. In other words, I took this 3 factor and this 9 factor, and I got 27. I'm left with m, I'm left with v, I'm left with the half, and I just pulled the 27 out. So I've got 27 times this quantity, and this quantity was, lo and behold, the kinetic energy of ball A. So ball B has 27 times the kinetic energy of ball A. And that's something that you need to know how to apply and work with and do those kind of things. So now let's move on to power. Power, we talked about briefly. That's the work done per time. So anytime you have a ratio over time, this is the rate at which work is done. All right, so it's the rate at which work is done. So let's look at the units of power. Power is work over time. The units of work are joules. The units of time are seconds. So the units for power are going to be the joule per second, and that is known as the watt. Sometimes power is measured in English units as horsepower, HP. So it could be measured as horsepower. It could be measured most commonly in terms of watts, or you can express it as joules per second, because a joule per second is a watt. So 1 joule per second is 1 watt. There's our units for power. And it's just that's pretty much all we really have to know about power. We need to know that it's work for time, so you might want to remember this. You might find the work done in a certain time. Work over time will give you power, and these three guys are the units that can be used. We're going to focus on this one, and this one happens to be that. So a watt is a joule per second. All right, so that's it with this video. We'll continue in the next review video.